Okay, next speaker is Mr. Engen. The title is How Python Helped Create the Emmy Nominated Visual Effects for Vikings. Please welcome Engen.
Hello. Can you hear me okay? Okay, perfect. So my name is Engin Arslan, and I worked in the visual effects industry for 5 years as a lighting artist slash TD. As a lighting artist in the visual effects industry, my responsibilities included creating a photorealistic virtual scene that is aesthetically pleasant, that is continuous with the live action footage, and that is helping the narrative, the story. I worked in movies and movies such as Resident Evil, Tron, The Thing, and I worked on TV shows such as The Strain, Penny Dreadful, Vikings, and Home's Inspection. This last one is a little random. It's a home renovation show from Canada, but it was my first job, so it's a little iffy. Anyway, so during my career in visual effects, I fell in love with programming, and especially with Python, because almost all the software applications that we use in visual effects have a Python API. So I decided to immerse myself completely in software development. And recently, I became a full-time front-end developer at a company called MyPlanet, a Canada, Toronto-based digital services company. And I'm also a part-time professor at Seneca College, again, based in Canada, Toronto. And I'm teaching visual effects artists about programming. And I'm also an author at Pluralsight. So the last project that I worked on in my visual effects career, the third season of Vikings got nominated for an Emmy Award for the visual effects, outstanding visual effects category. We unfortunately lost it to some show called Game of Thrones, but it was still an awesome experience to be part of this show and do the effects that we did for it. And in this session, I will be talking about how we were able to leverage the power of programming and the power of Python to be able to deliver the effects that we did for this show. And we actually won a Canadian Screen Award for the show, but to be fair, the competition was less fierce in Canada than in the United States. Anyway, so programming in visual effects. I would like to actually give you a general overview of how programming is used in visual effects before delving into the specifics of that one TV show. And if I'm to categorize, I can actually describe it in 4 different sets. First of all, we have computer graphics research and development, where we have really smart people, people with computer graphics, math, physics, PhDs, that are driving really low-level research and development in subjects such as simulation, shading, and rendering algorithms, etc. So they either extend the possibilities of the software applications that are in use in the studios, such as Maya, Houdini, 3ds Max that you might have heard of, or they create entirely new tool sets for artists to use. Obviously, the work of a wizard, I would like to call these guys as wizards because they're like geniuses. Obviously, the work of a wizard can give lots of leverage to your studio if you can afford to have one, right? And if you can't afford to have a wizard in your studio, then you might fall a little short in the results that you can come up with, or you might need to get a little hacky because you will be using off-the-shelf tools at that point. And next off, we have pipeline engineers and developers, people that work on the tool set of the studio. That's the tool set that is managing the data flow in the studio in between different departments that you would have in a visual effects production. Departments such as modeling, animation, lighting, etc. So I will be delving into the duties of these departments as well, more in detail. But for now, we only need to know that these people don't necessarily work with the visual aspect of the things, but they facilitate the production by working on the studio tool set. And then next off, we have technical directors. Technical directors are technical people that are situated at each department, again, departments such as animation, lighting, etc. And they work on their department's problems by creating technical solutions for those, such as writing scripts, plugins, or specific solutions based on the tool set that is being used. Nowadays, since I'm a front-end developer, I would like to think of technical directors as actually almost like front-end developers in a sense that they will be working with other tools that other engineers have created, such as the pipeline engineers, etc. And they will be working on the client sides or like the viewer-facing side of the production, right? And finally, we have eager artists, artists that are not necessarily programmers, but they are frustrated by the limitations of the tool set that they are using. For example, if you're using Maya, you might be frustrated by the limitations that you have. And they are people that are leveraging the scripting API of the software that they have to create automated solutions. So almost all the software nowadays that is used in visual effects have a Python API. So if I'm to name the software for you, if you are curious, we have Maya from Autodesk, big company, SideFX Houdini, and Foundry Nuke. All these applications that are doing various different things in visual effects have a Python API so that you can actually script them and automate your workflow. Moreover, they would be implementing their own visual interface using a library called, like a library such as PyQt or PySite, so that you as an artist or you as a developer can actually open these applications and start developing your own visual interfaces in these applications, or learning something like PyQt. It allows you to develop desktop applications as well, right? Which allows you to maybe contribute to the pipeline tools in your studio. So Python dominates the visual effects landscape, except for tasks that are more performance critical, where something like C++ would be more useful. So a little bit of a personal history. I started my career as a lighting artist, but upon realizing the power that Python brings you in visual effects production, I decided to learn more about programming and learn more about Python. And I slowly transformed myself from an artist who can do coding, like slowly from an eager artist who can script a little bit scripts, to actually a technical director who can work on shots. And I worked in lead positions in some of the shows that I worked on as well, such as the movie Mama, the TV show Strain, and the TV show Vikings. And especially for TV shows, the need for automation becomes really pronounced, because in a TV show you have many episodes, and the TV show kind of provides you with like similar looking challenges. So you would have lots of repetitive shots that you need to work on in a TV show. So that's an example from the TV show Strain. TV show Strain is a show about vampire / zombies that are like sucking the blood of their victims, using these tentacles that like come out of from their mouths, right? And we had to work on like hundreds of shots like this. This can get really boring for an artist. But as someone who's fascinated by developing tools and developing automated solutions, this was really entertaining for me, because it kind of poses you the question, given that you are controlling for the inputs, what I should be optimizing in my own department to be able to make my department more efficient, right? So it allowed us to think in terms of the efficiencies, etc. So that kind of put me in the mindset of automation in the visual effects. So first 2 seasons of Vikings was really repetitive as well. But once we received the script for the 3rd season of Vikings, it turns out it was a whole different beast, because the scope of the project immediately grew from like small effects to a huge full CG shots that we needed to do, which contained things like Viking warriors invading Paris. So this is not a storyboard image. This is an image that I found from Wikipedia. But this is basically essentially what we needed to create for this show, where like Viking warriors would be invading the city of Paris you would have the sea, vegetation, the Viking barriers, the fire, etc., and they all needed to be computer graphics. So this is a huge challenge to undertake, especially if you are working on a TV show, because TV show budgets are much smaller than the movie budgets, depending on the TV show, probably, but that was somewhat the case for Vikings. So we were like a little bit more constrained in the things that we could do. So we needed to come up with innovative solutions. And this is like where the Python and the programming aspect of the things kick in. Because once I looked at it, I was like immediately thinking to myself, I need to automate this, or else I can't deal with this much data. Before delving into this project, though, I will give you a brief overview of how Visual Effects workflow operates. So in Visual Effects, and this is going to be a really simplified overview of it. So in Visual Effects, you would have a clean footage, clean plates, and this is the footage that is shot with the camera. And this is the footage that you need to add CG elements in. So then you would be doing modeling. Modeling is the creation of assets that would be used in the movie or the TV show. And in our case, it was like, for example, things like ships or Viking barriers, etc., that needed to be modeled in. And this modeling can be done using photographic reference or 3D scan reference. And after modeling, I guess after modeling, you would have layout and animation, where layout would take these models and would place it into the scene, choreograph the scene. And in animation, they would be animating these models, right? So these ships that you can see in the screen might be like tumbling in the water, or you might have Viking barriers that need to be walking around, etc. So that's the duty of the animation department. And then next up, we have texturing and shading, where like surface qualities of these models are being defined by using, again, photographic reference, etc. And in shading, you are defining the material qualities of a surface, how a surface reacts to the lighting in the simplest terms. And after all these departments are done, and I'm skipping a lot actually, for example, you might have an effects department as well, where they would be adding effects to the shots. For example, they might add a little bit of a rippling effect in the water, or they might add a little bit waving to the flags in the scene, etc. And then next off, we have lighting and rendering, where I was situated in, where you would get all this data, all these 3D models, all these files, etc., and you would try to create a photorealistic scene. And then you would render it off. Rendering means flattening of this 3D information into 2D. And then you would send it off to compositing department, which flattens, which finalizes the shot. So that's basically the summary of what it is, how visual effects workflow works. I have a video of the final effects that we have created for this TV show, but I'm not really sure. So this computer is not connected to audio right now, so we will just be looking at the images. But I just want to show you how. Oh, it's not playing over there. So I guess I can do this. I just want to give you a little bit more context as to what we created before talking about what are the specific things that we did for this show. So I was working at a company called Mr. X when I was working in the effects for this show. And this is the demo reel for the TV show Vikings, displaying the effects that we did for it. So all these effects that you would be seeing in this demo reel was done only for one episode of this TV show, actually, which is kind of crazy because TV shows have many episodes, and we only had, and we are only showing like what we did for one episode of this TV show. So yeah, you can see the steps here where like you have the clean footage, and then you have the models which get textured, and then layout places those models into the correct places, and then we light and render them to make them look more photorealistic. And then the compositing department comes in and adds more effects, finalizes the shot. As things like lens distortion, or like lens effects or color grading, etc. And it doesn't happen as easily as you can see in the screen, obviously. Like, it just like shows it to you in a second, right? But like for some of these shots, we have worked for months trying to get the correct look. So yeah, we would have just that part of the clean plate, and everything else is fully computer generated for this shot, for example. And this was one of the particularly challenging shots where we had to have the entire city of Paris, Viking warriors invading the city, digital water, ships, etc. A lot of things. And we needed to have this camera zoom out happening from a really close-up shot. So I'm not going to, I mean, it's almost over, but this kind of summarizes like the types of effects that we worked on for this show. And at this point, I would like to actually discuss what are certain things that we did, how are the ways that we leverage programming and hence Python in trying to create this TV show, right? And I would like to categorize our approach in 3 schools of thought. First, so it's going to be a high-level overview still. So the first school of thought that I would like to mention is approach that I would like to label maximizing optionality. And this derives this inspiration from an author called Nassim Taleb. He's the author of books such as Black Swan or Anti-Fragile. And in his book Anti-Fragile, he remarks something really interesting. He says that if you have optionality, if you have enough options, that is, you don't necessarily need to be too intelligent or skillful when making decisions, as long as you can recognize favorable outcomes. So this is a really interesting remark, and I found out that this idea maps really well to the lighting process, actually. So how lighting process works is that this is a GIF that is showing you that process really roughly. And how it works is that we will be receiving those digital assets that I was talking about. And in that virtual scene that we would have, we would try to place virtual lights that are representing real light sources into the scene to get a photorealistic result, right? The catch here is the rendering that needs to happen before you can see the results of your actions. And rendering can take a while. Here we are seeing a progressive rendering that is like happening in a few seconds. So the image is muddy at first, but it then gets clear and clear. So this is taking a few seconds, and this is happening almost real time. But sometimes rendering can take a long time. It can take like few hours almost, even though it is a test render, depending on the scene complexity. So, so that makes experimentation prohibitively expensive. And once you can't experiment as an artist, you are severely constrained in what you could be doing, right? So that makes lighting a little bit of a challenging process. But what I noticed is that instead of waiting for this rendering process to happen, why don't I, like for like a single decision that I made based on the lighting, etc., why don't I render all the light possibilities in the scene? What I mean by that is that if you think of a lighting that can happen in an environment, it is going to happen in a hemisphere that is surrounding whatever your assets are, right? So a light here in this room can exist only in a hemisphere that is like surrounding us. Like it is not going to exist, like it is a limited set of options. And the angles that it can exist is a limited set of options as well. And the settings on the light, the configuration of light is a limited option set as well. So what I figured is that why don't I render all these options instead of trying to decide beforehand, of course with a reasonable step size, so that I can defer this decision making to batch processing and defer my artistical decision to a post process so that I can make decisions instantaneously. So here's an example of that. I'm rendering all the lights that are possible around this one asset, and I have a light that is rotating 360 on a hemisphere around this asset, right? And what I can do at this point is that I can make immediate decisions looking at this image. I can be like, oh, I like the light on this frame. I like the light when it is on this angle, etc. And I can start compositing them in real time. So I'm not making decisions in during rendering, but I'm making decisions in a post process, which makes my decision-making process instantaneous, where I'm getting like immediate feedbacks, right? So essentially what I'm doing is I'm trading the artist time with the machine time. Another place where we leverage this idea is with the high dynamic range images that we will be using in visual effects. So in visual effects, we will be taking these photographs that are high dynamic range images that are captured during the day of the shoot. And the reason for these images is that we can actually use these images to create photorealistic lighting really easily. But these images usually stay dormant in the hard drive because they're only captured for a certain shot, right? So the idea that we had was, why don't we use all these images that we captured for a TV show and render our assets through all these images so that we can see that if our assets are working for all the conditions that exist in the TV show. Again, we are leveraging optionality. We are leveraging abundance of options to be able to make decisions, to aid our decision-making process. And this is only possible by leveraging computation and leveraging obviously the hardware power that we had at the time, where we were using like 500 or so machines to render our images. So if you don't have that kind of a hardware power or like computational power, using optionality and like automating this kind of a process might not make too much sense. But if you can afford the computational power, it is a reasonable thing to do, so that you as an artist are not constrained by the limitations of time, basically. Another school of thought that I want to delve into is checking with diligence. So the inspiration for this comes from a book called Checklist Manifesto. It is written by a doctor called Atul Gawande. And in his book, Atul Gawande talks about how really sophisticated industries such as construction, aviation, or medicine can actually benefit from the usage of something as simple as checklists. Atul Gawande is a doctor, so he gives an example from the field of medicine. He talks about how doctors or how in surgery rooms, you would usually, there is a risk to forget surgical instruments inside a patient's body. So that's actually a common mistake that would happen pretty frequently, unfortunately. And that's a fatal mistake at times as well, right? But by utilizing something as simple as a checklist and asking yourself the question, did we account for all the instruments that are used in the surgery, you can actually minimize this error. You can virtually make it 0%. So that's the observation he has. And he looks at construction, he looks at aviation, and he sees examples of this everywhere he looks. And considering a CG program can have as many buttons as a cockpit of a plane, it makes sense to actually utilize checklists in 3D applications as well, in visual effects as well. Because what can happen is that, as I told you, rendering can be a slow process. But I was talking about test renders at that point. If you are doing renders for production, production can be a 4K production, right? It can be like a 3D production. So rendering can be a really expensive process. For a shot, you could be rendering frames for 24 hours, which means that to see the results of your images, you have to wait till the next day. So it becomes really essential at that point to minimize human errors. And when you are dealing with interfaces like this, human errors are really possible. So you can actually leverage Python scripting, again, using the Python API, to enforce checks on yourself, to make sure that you are getting things right. And it is essentially about getting stupid things right? Because you don't necessarily need to be dealing with remembering all these small details when working as an artist. You want to be creative and freed from the constraints of these arcane interfaces, basically. So Python helped us, or programming helped us, impose constraints on us in the form of checklists, etc. And the final school of thought that I want to delve into is that everything teaches something. So this is a little bit of a personal one. The inspiration for this category comes from a book called The Art and Science of Engineering by Richard Hamming. And he has a quote in that book where he says that it's worthwhile now and then to examine background things which never held your close attention before, since great steps forward often arise from such actions and seldom otherwise. So to me, what it means is that as I was working in the visual effects industry, and as I was creating these tools for this TV show that I was working on, as I told you before, I was actually falling more and more in love with programming. And I decided to position myself as a web developer because I figured in web development as being a front-end developer, I can still be working with visuals, but I can be doing more coding. So I decided to join meetups. I decided to go to conferences, etc., to develop more knowledge in the field. And one of the conferences that I went to at the time was Jquery. So Jquery, if you are not really familiar with it, is a JavaScript library that makes easy to query and manipulate the HTML markup, the DOM. So with Jquery, you can write really concise queries such as this, which would work on the HTML page, HTML markup, and would do something like looking at the body elements, finding the children paragraphs in that body elements, finding the sibling div elements inside the paragraph, etc., etc. This almost reads like English, so I'm not going to delve into what exactly it does, but it finally, after like chaining all those methods, it changes the color of the found elements to red, for example. This one-line statement does that really easily. So the beauty of Jquery really is impressive, like was impressive to me at the time, because I figured that when we are doing lighting, we are actually working with a similar challenge as well. When we are working in a 3D scene, we have a really hierarchical scene where like things are really deeply nested in each other. And sometimes we need to manipulate that scene as well. We need to do queries on that scene as well. So I created a library called Jquery, which is working in these 3D applications. And what it can do is that it can look at your scene and find, for example, nodes that are named Vikings. So find all the Viking warriors for me, find those that are belonging to the Lagertha clan based on the file name, and from those Lagertha clan Vikings, choose their axis and hide a piece in their axis in that scene, right? I want to hide that scene. I want to hide that piece because maybe it is rendering too slowly, maybe it's not needed in that scene, maybe in the previous scene they removed it, etc. For whatever reason, I want to do that manipulation. And thanks to that library, we were really able to do this easily and really quickly without like having to delve into our scene and clicking buttons, etc. And the interesting thing is that the inspiration for that came from a JavaScript library, a web development library. And one other inspiration for that was, as I was learning more about web development, as I was developing myself more of a JavaScript developer, I found out that it was actually helping my Python development skills as well. Some of the functional ways of working in Python, such as like using decorators, etc., made more sense when I looked into JavaScript. So learning something definitely helped me in that instance. Learning something different definitely helped me in that instance. So I would like to go back to this quote where Richard Hamming is saying that like looking at some background things can help you actually forward your understanding in your own domain. So I would like to actually wrap up this talk by saying that, by actually mentioning that the examples that I gave you, for example, Nassim Taleb is actually a trader, he's a quant, but he's now a philosopher. Or Atul Gawande, the writer of the book Checklist Manifesto, is a doctor, but he was able to derive his inspiration from the field of medicine. And I was able to derive inspiration I was able to derive inspiration from the field of web development as I was working in visual effects. So I would like to wrap up by saying that thank you for coming to this talk, which probably has nothing to do with your problem domain, but I hope that you will be able to take lessons from it and be able to apply it to the problems that you are faced with. Thank you.
Thank you very much for your talk. And we don't have enough time to Q&A. So
Okay.
So if you have any question, please
Outside? Or
outside or yeah, outside or
okay.
Somewhere else.
Sure. Thank you.
This conference. So please ask later.
Oh, okay. We were running on Linux. Yeah, mostly. And I think Visual Effects Studios use mostly Linux. Yeah. So yeah, that was our choice for that. Thank you.
So please give him big hand.
Thank you. Thank you.